Welcome back to MKE Gadgets. Today we're going to fix something I got off the curb. And all we're going to need is a piece of PVC elbow. What I acquired from that curb is this beautiful Shark vacuum cleaner. It's model NV355. First thing I did when I got it off the curb is made sure the motor ran, the switch worked, and there was no cracks in the cord or any of the hoses. No problem with that. I took it all apart, cleaned it, vacuumed it out, blew it out, and got all the dirt out of there. So in using it and cleaning it, I realized I was missing a piece. This would not fit in there from the manufacturer because it's just too loose. So I feel that there's a piece that kind of looks like an elbow. So I could make one many different ways, but I thought, well, what do I have around here, or what could I buy very inexpensively and turn it into an elbow that's easy to machine? I came up with this. This is a street elbow, 1.5 inches. A regular elbow has 2 female ends, and a piece of pipe would just fit in there and that'd be glued in there. A street elbow has 1 female end and 1 male end. And I picked this because this is what I had. First thing I did is I wrapped tape around here to make sure that would fit and stay in there. Now there's no pressure on here. And in fact, there's a vacuum because this is a vacuum. So it would suck this tight. So it's not gonna blow it out. So what I have to do in order to make this fit in there, I gotta remove very little material, about 15 thousandths of an inch. Now there's many ways to do that. One way to remove that extra material would be a die grinder. This is plastic and it doesn't really work really well with a die grinder. This is gonna spin at 22,000 RPMs and it's just gonna melt it. But that's one way of doing it. Another way is you put a sanding drum in a die grinder or your cordless drill, your drill press, and you go in there and you remove the material. Now this isn't spinning so fast, but it's gonna heat up and it's gonna mush. That might work. What I did, I used my Bridgeport mill. I clamped this in there, leveled this off so it's level in 2 directions, indicate the center end, and bored it out. Let's go over to the Bridgeport mill and see how this works. Okay, at the Bridgeport mill, I want to bore this out to 1 inch, 950 thousandths. So I have it in a vise, and I have it clamped down here, and I indicated it with my indicator here. And if we sweep this around, I have it indicated within, well, going that way about 1 thou, and going this way about 1.5 thou, which is pretty good considering this is a piece of plastic. And if I squish it with my fingers, I can move it. I just don't want this to break free from my clamp and the jaws while I'm milling it. And I also want to make sure I'm flat and level. So let's check that next. So with the digital level, I'm flat there, which is really good considering this is a piece of PVC. And if I turn it 90 degrees, and at 90 degrees, I was out 0.2 degrees. For what I'm doing, that is really pretty good. Next, we're gonna bore this. So here's my boring bar. It's a single point boring bar. I'm gonna place it in there. The boring bar, you loosen the gib here, there's 3 little screws, and then you advance this screw. This isn't metric, and my size isn't English, so I gotta do a little converting each time. But down here, you can see where the tip of the insert is not touching the stock yet. So I'm gonna loosen this up and move it over a bit. So I wanna sweep it on all 4 corners and make sure I'm not touching. And then I'm gonna advance the head a little bit more and then sweep all 4 corners. All right, I'm just about touching. So I'm going to tighten up the screws, 3 screws here for the gib. So now when I go down, I should not take a cut at all. I want to set my Z height, so I'm going to come down to the bottom and just clear out my Z to 0. Okay. Loosen these screws up. This is kind of tedious because you got to loosen up these screws. Advance the screw. Tighten it up. Now I'm going to make a note where my 0 is. I got a little flashlight here. The witness line is a half a line past 0. So I'm going to make a note of that. And I'll turn on and see if we do any cutting. Just, I don't know if you can see this, just very lightly cutting on this one side. So I am making contact with the part. Now remember, this part is a little bit out of round, and it's indicated in within 1/1000 and 2/1000. And then tighten it up again. And I'll turn on and see if we do any cutting. Okay, let's check this. I know I'm getting close. Boy, that's really a snug fit. It looks like I'm going in deep enough. Let's take this back to the table and put it in the vac and see how it fits. Probably better than a factory one. Get that in there, and look at that, it's repaired. Now I looked up online, this vacuum cleaner goes for $250. I got it off the curb, cleaned it up, modified it elbow. You can get it at most hardware stores or big home centers. Cost of this elbow was 79 cents. A little bit of tape, and now someone's gonna get a very nice Christmas gift. A lot of people ask me, what can you do in a Bridgeport mill? There's many things you can do. Repairing a vacuum cleaner is just one of thousands of things you can do. I use the Bridgeport because that's what I have. But if I ever find a vacuum on the curb, usually there's 3 things wrong with it. 1, the cord is cracked from being wound and wound and wound too many times. 2, the switch doesn't work. Or 3, it's just dirty and needs a cleaning. The only thing wrong with this was, it was missing this part. This is MKE Gadgets. I hope you found this entertaining, informational, and interesting. Please subscribe to my channel and tell your friends. See you tomorrow.